Welcome to Methamphetamine. Today we're gonna do the integral of sin x plus cos x over 1 minus sin x cos x from 0 to pi over 2. How can we do this integral? Here, I would like to get rid of the sin x plus cos x dx on the top. So, I want something like sin x minus cos x here. Because why? If you differentiate sin x minus cos x like that, you get cos x, and then the derivative of cos x, you get negative sin. So over you get just this positive sin. So over you can use up here. If we can get something like sin x minus cos x on the bottom, so you can let u is equal to that, and then our top is just equal to our d what? And high just get u on the top. So, however, what can we do though? Here's the deal. Let me just try to square it. Sin x minus cosine x like that. Squared is really cool because size you can write it as expand it as sin square x minus 2 sin x cos x and then plus cosine square x. Use our formula. A minus b squared. A is the famous identity. Sin square x plus cosine square x is just equal to 1, but 1 minus 2 sin x cosine x like that. So overall, what's our deal though? We can change it. If we get a 2 here, we can just change into sin x minus cos x squared, right? So I want a 2 here, right? So let me just multiply by 2 like that. From 0 to pi over 2 and then sin x plus cosine x. And then here, let me just write as 2 minus 2 sin x cosine x like that. You multiply by 2. But don't forget, you have to multiply by 2 here. Because you just cancel each other, you will get the original back. Make sure you don't change anything. Don't change the original question. And then factor the 2, you just cancel the 2, you will get the original one. Original question. And then here is the deal. Sin x plus cos x like that. 2 minus 2 sin x cos x. I want a 1 minus 2 sin x here. Let me just write as 1 plus 1. What I say 1 plus 1 is equal to 2, right? I really say it. 1 plus 1 is equal to 2. And then minus 2 sin x cos x. You get the original back. Here's the deal. I keep saying here's the deal. And then here 1 minus 2 sin x cos x. We know that this is just equal to sin x minus cos x squared, right? So overall, this is really happy. We can just let let me just let t. We can use t or u, up to you. Let t is equal to sin x minus cos x, and then our dt is just equal to cosine x and then plus sin x. Don't forget to put the parentheses and then multiply by dx like that. So sin x plus cos x is totally equal to cos x plus sin x. The order doesn't really matter. The order doesn't matter. The order doesn't matter. Like that. So on the top you just get, but be sure you need to put 0 into it to figure out what's our lower limit and upper limit in our T row. Put 0 into it. You get sin 0 is equal to 0. And then cosine 0 is just equal to 1 here. But in front you have a negative, so over you get negative 1. Put pi over 2 to here. Sin pi over 2 is 1. And then cosine pi over 2 over you just subtract 0. So over you get 1 here. You roll up from negative 1 to 1. And then over on the top you just get 1. Multiply by dt like that. And then 1 plus our t square dt like that. Here we can double the result. 1 over 1 plus t squared from negative 1 to 1, the integral. What? You can let f of t equal to the entire function, and then put negative t inside. You can check it whether an even function or an odd function or not, and you can do it by your own, and this is just an even function, so you can double the result, so you can get 4 times this integral from 0 to 1, and then 1 over 1 plus t squared dt. So over the integral of this 1 over 1 plus t squared is just inverse tangent of t, right? And here we're gonna put 0 and 1 into it. So over inverse tangent of 1, you get pi over 4. So 4 multiplied by pi over 4, and then subtract. So inverse tangent of 0 over is just 0, so subtract 0. So 4 and 4, they are cancelled. So overall, the final answer is just equal to pi. It's really, really cool.